Welcome again, ladies and gents. Today, this flipped lesson is going to focus on what the mole can do for you. And specifically, our very narrow focus is going to be on calculating the molar mass. So we learned yesterday that 1 mole is equal to 6.022 times 10 to the 23rd. So to help you remember what that number means, remember it's a counting unit just like a dozen. So if I say I have a dozen of something, I know that means I have 12. So when a chemist says they have 1 mole of something, it means 6.022 times 10 to the 23rd pieces. Now that number is such a huge number because our atoms are really teeny tiny. So we need a lot of those teeny tiny atoms to make up 1 mole of a substance. We also learned yesterday that that idea of the mole comes from the periodic table. And we're able to understand that each element on the periodic table represents 1 mole of that substance. So with that information, we can use it to calculate something called the molar mass. So when we're looking at the molar mass of an element or a compound, what we're referring to is how many grams we need of that substance to get us to 1 mole. So if you remember from class yesterday, we did some calculating with some different isotopes, and we all got 6.022 times 10 to the 23rd for our answer. It's because the mass on the periodic table represents 1 mole of that specific element. So if I ask you for the molar mass of an element such as copper or hydrogen, all you have to do is look at the periodic table and copy down the mass, because that mass is how many grams I need for 1 mole. So if I want to know the molar mass for copper, I look at my periodic table in the transition metals, and I can see that it's 63.546, I believe. Yep. And then my unit on that is going to be grams per mole, because those masses represent the number of grams that I need for 1 mole of that substance. If I want to do hydrogen, I do the exact same thing. I find hydrogen on my periodic table, and I copy down its mass, which is 1.0079, and again, that's grams per mole. So if you have a single element, getting the molar mass is quite simple. If you have a complex compound, it becomes a little bit more difficult because that compound is going to entail multiple elements. So we're going to go ahead and we're going to talk about how to get the molar mass of a compound using BeNO32 as an example. When I'm looking at this compound, what this compound tells me is I have 1 Be. This 2 on the outside means I have 2 NO3s. Each NO3 is 1 N and 3 O's. So if I multiply, I have 2 of my N's in that compound, and I have 6 O's in my compound. So my molar mass is going to be a little bit more complex because I have a lot more of these elements present. So to get the molar mass of a compound, what you do is you add the individual elements together. And if you have more than one of them, you multiply the molar mass by that number. So if we do this example, there's only 1 Be, so I look at my periodic table and I see that a Be is 9.0122. So that's the mass of 1 Be. I've got 2 of my nitrogens, so I'm going to do 2 times the mass of 1 nitrogen, which is 14.007. Oops. Which gets you to 28.014. And then I'm going to do my O's. This isn't a U, that's an O. That's a really bad O. But I've got 6 of them. So I'm going to do 6 times the mass of 1 O. If I look at my periodic table, I see that 1 O is 15.999. So I do 6 times 15.999 to get 95.994. So this is the mass of each element that's in this compound. So to get the molar mass for BeNO32, I'm going to add these 3 masses together. So I'd add 9.0122 plus 28.014 plus 95.994. When I enter that into my calculator, I get a total mass of 133.0202 grams per mole. Now, one thing you'll notice, I'm not rounding any of these numbers. When you're getting molar mass from the periodic table, you do not round. You just take all the numbers that you get on your calculator. So it's way easier than having to remember sig figs. So what I'd like you guys to do right now is I'd like you to hit pause and try getting the molar mass of H2O yourself. When you're done getting the mass, go ahead and come back and check your answer. So you're back. I'm guessing that means you've already gotten the mass for H2O. So if we look at the compound, we've got 2 H's and 1 O. So I'm going to add together 2 times my hydrogen, which is 1.0079, to 1 oxygen, which is 15.999. So if you did it correctly, you should get a mass of 18.0148 grams per mole. And that's it. That's calculating molar mass. All you have to be able to do is look at your periodic table to find the element, and then multiply it by the number that you have present if necessary. So what I'd like you guys to do right now is head over to your Google form. I have 3 examples I'd like you to try based off this video, and we'll start class by talking about those tomorrow. Have a great night, guys.